All right, college algebra today. We're looking at inverse functions. All right, inverses. Here's a relation right here. And this is a function because each x has only one y. Okay, well right here, this is the inverse. And if you notice, the x's and y's are switched. Okay, now in this one, each x only has one y. So this is a function, which means these are 1 to 1, which means each x has only one y and each y has only one x. So inverses have to be 1 to 1 to be, or functions have to be 1 to 1 to be inverses, to have an inverse. All right, this is the notation. This is a function, and this is the inverse function. Okay, so that's what the notation looks like. And then, of course, we'll have this we'll look at here in a little bit. How to determine if two functions are inverses. If you do f of g of x, you should get x. And if you do g of f of x, you should get x. And that tells you they're inverses. So we'll look at that in a minute. And then we also have this right here, finding the inverse. If you have a function and you want to know what the inverse is, here's how you can find it by doing these 4 steps. And we'll get into that in just a little bit. Okay? All right, so first off we have here, for a function to have an inverse, it must be 1 to 1. It must be 1 to 1, which means each x has only one y and each y has only one x. This is 1. Okay, that's what 1 to 1 means. So a function has to be 1 to 1 for it to have an inverse. Number 2, select the correct choices. If two functions f and g are inverses, then f of g of x equals x and g of f of x has to equal x. Okay. All right, then we come down here, number 3. The domain of f is equal to the range of the inverse. And the range of f is equal to the domain of the inverse. So the domain in the function is the same as the range of the inverse. Okay? And then number 4 here. If the point AB lies on graph of f, and f has an inverse, then the point, all right, we switch them, BA. BA would be on the inverse. So if AB is on the function, BA would be on the inverse. Okay? Now let's go number 5 here. Decide whether the function is 1 to 1. All right, here's where we just simply have to know what the graph is, what the function is itself. And this is linear, which when you graph this, now this is not what it's going to look like maybe, but something like this. It's going to be a straight line. Which, to look at the graph, it should be a function, which means it passes the vertical line test, but then you also have to be 1 to 1. You have the horizontal line test. And each horizontal line can only cross it once. So yes, this is 1 to 1. Okay, now if you look at number 6 here, see we have 2x plus 1 squared minus 6. This is quadratic, which I'm not going to graph the actual graph, but it's going to make a parabola like this, which is not 1 to 1. This is a function because if I draw vertical lines, it passes the vertical line test, but it does not pass the horizontal line test because it touches it twice. So no, and you see the answer right there, it is not 1 to 1. So anytime you have a quadratic function, it will not have an inverse because it's not 1 to 1. Number 7, okay, here's like in the terms of activity or something, tying your shoelaces. What would be the inverse of that? Well, untying your shoelaces would be the inverse. Okay, and then now number 8. Here's where we get into what we were just talking about a while ago. Okay, we'll go back to this paper here. If two functions are inverses, f of g of x equals x and g of f of x equals x. Now, most times if you just do one of these, then that's sufficient to tell you that they're inverses. All right, so you get a piece of paper here. We'll try doing one of these. I might have room right here. All right, so f of x is this, and here's g of x. All right, so what I want to do is I want to do f of g of x, which means I'm going to take the g function and put it in the f function. Okay, well, here's what that's going to look like. My f function, I'm just going to write it out, 4x minus 12. Okay, and then right there where x is, I'm going to put the g function, which is x over 4 plus 3. All right, then I'm going to simplify this down, and I should get x if they're inverses. So when I distribute here, I got to distribute this 4. So 4 times x over 4, well, the 4x divided by 4 would be just x. And then I do 4 times 3, which would be 12. And then I got this minus 12. And then these two cancel, which means I just have x. So yes, they're inverses. Okay. What about number 9 here? Determine if these are inverses. All right, so I'm going to do f of g of x again, which means I'm going to write out my f function here, negative 3x plus 10. Okay, and then right there where x is, I'm going to put the g function in its place. The g goes in the f. So I've got negative 1/3 x minus 10. Okay, and then I simplify this down, and I should get x. So when I distribute here, negative 3 times negative 1/3 would be a positive 1x, so that looks good. Negative 3 times negative 10 would be a positive 30. Then I have the plus 10 here, and this is x plus 40. I don't get x, so no. And you can see the answer there, no. Okay, number 10. Use the definition of inverses to determine if they're inverses. All right, so I'm going to do f of g of x again. F of g of x. And so I'm going to take the f function, which is 5x plus 4 divided by x plus 9. Okay. And then I'm going to put the g function in there, which is 9x minus 4 divided by 5 minus x. And then down here, 9x minus 4 divided by 5 minus x. Okay, now this is going to be a little bit tougher. Okay. All right, so what I'm going to have to do here, I need to multiply top and bottom of this, 5 minus x, so I can have the same denominators here. And I'll do it up here too. Okay. All right, so now I distribute 5 times this would be 45x, and then 5 times negative 4 would be negative 20, plus 4 times this would be 20, and then 4 times negative x would be negative 4x, and that should all be over 5 minus x, since I got common denominators now, 5 minus x. Okay, that's the top. On the bottom here, okay, I've got 5 minus x would be my common denominator. I got 9 times this, so I've got 9x minus 4 right here, plus 9 times 5, which would be plus 45. And then 9 times negative x would be negative 9x. And all that's over 5 minus x. Okay. All right, so now from there, get a little sheet of paper. Okay, I got a fraction divided by a fraction. So that means I'm going to keep, change, flip. I keep the top one, which is 45x minus 20 plus 20 minus 4x over 5 minus x times, and then I'm going to flip this guy, which means I'm going to have 5 minus x over 9x minus 4 plus 45 minus 9x. Okay, so that's what I have there. I keep, change, flip. I keep the top one, change to multiply, and then I flip the bottom one. And when I do this, okay, I probably need to add my like terms here, but I already see that these are going to cancel. So it's going to be this expression over that expression, because these cancel out. And then I'm going to add my like terms, so 45x minus 4x would be 41x, and then negative 20 plus 20 cancels. Okay, on this one, this is on the bottom, I got 9x minus 9x, which cancels, and I've got negative 4 plus 45x, which is 41, and the 41s cancel, which means it's just x, which means they are inverses. That was a little tough one, but these are inverses, so yes. And you see the answer there, yes. Okay, that's probably the hardest one. Here's another one. Use a definition of inverse here. So we'll do the same thing. Okay, so I'm going to do f of g of x. So I'm going to take my f function, which is 3 over x plus 7. And I'm going to put this g1 in there. So I got 7x plus 3 over x. Okay. So I've got 3 over this. I need to get these together, which means I need to multiply this one x over x. So they give me 7x over x. So I've got 3 over 7x plus 3 plus 7x, and all that's over x. Okay, because I got common denominators here now. I had to multiply top and bottom by x, so I have the same denominators, which means I have 7x plus 3 plus 7x, all over x. And now I'm going to do the change flip. I'm going to keep my 3, I'm going to put it over here. I'm going to change to multiply. And I'm going to flip this one, which means I have x over, and that's going to be 7 plus 7, 14x plus 3. Okay. Now what I could do is I can multiply top and bottom of this one by 14x plus 3 over 14x plus 3. So I'd have common denominators here to add to, oh no, it's multiply, I'm sorry. This is multiply, forget that. So this is going to be 3x over 14x plus 3. I was thinking as an add. But I'm not going to get x here. So this is no. This is a big no. I think you see the answer right there. Okay. Now moving on to number 12. Number 12. If function is defined by the following is 1 to 1, find the inverse. All right, this looks like it's 1 to 1 because each x only has one y and each y only has one x. All right, so what's the inverse there? I switched those, so it's going to be 6, negative 4. Then we'll have 2 and 3. Then we'll have 9 and 4. And you can see it right down there. Okay. All right, so that's easy. Number 13. All right, here's another one, same thing. So if it's 1 to 1, find its inverse. All right, so, oh, this is not 1 to 1. Because right here, see how 3 is paired up with 3, and I've got 6 paired up with 3. Which is a function, but it's not 1 to 1 because each y here, see this y has 2 different x's. So it's not 1 to 1. It is a function, but it's not 1 to 1. Okay, now let's go here, 14. You got this graph here. Decide whether the pair of functions graphed are inverses. All right, see this dotted line right here? Okay, that's y equals x. Inverses should intersect each other on that line, and you can see how they touch right here on that line, so that looks good. Okay, now all I need to do is check maybe a point or two. So here's this point right here. This point is 4, 2. 4, 2 is on the red function. That means if I switch those, 2, 4 should be on the blue one. All right, 2, 4 is right here, and it's not. It's not on the blue one, so these are not inverses. You see the answer right there? No, they're not inverses. Okay. 15 here. For the function 6x minus 7, determine whether it's 1 to 1, and if so, write an equation for the inverse. Okay. Now, 6x minus 7, just knowing my functions here, this is linear, which is 1 to 1, so it should have an inverse. So we're going to find that inverse. So here it is. Here's my function. Okay, now as I wrote on here a while ago, let me get this paper back. This is how you find the inverse. First, you change f of x to y. So that's what I'm going to do here first. Step 1, I'm going to change this to y. Okay, that was easy. All right, now step 2, I swap x and y. All right, so step 2 here, I'm going to change y to x, and I'm going to change x to y. And so there you go, swap them. That was easy. Now what you can do is you can just go straight from this to that, really, and do both them steps at once if you want to. Step 3, I've got to solve for y now. So right here, here's y. I got to solve for y, which means I'm going to have to add x, or add 7. This is step number 3. So this will go away. So I have x plus 7 equals 6y. Okay. And then divide by 6. And that will cancel, so y equals x plus 7 divided by 6, and there you go, I solve for y. Okay, and then we have step 4, change y to f inverse of x. All right, so y here, step 4, is f inverse of x, and it's x plus 7 all divided by 6. Okay, so there's my inverse right there. X plus 7 divided by 6. All right, so go down to your my answer. You see my answer right there. X plus 7 divided by 6. Okay. All right, now part B says choose the correct graph of this. All right, so it looks like on the blue line is the function. Okay, you can check that it crosses at -7. It looks like it goes up 6 and over 1. So that looks like these blue lines look correct for the function. All right, now what we can do to figure out which one's the inverse, you should think about this dotted line here that we talked about a while ago. And if I look at this one right here, okay, these two do not cross on that dotted line. So that tells me right there this is not right. It can't be that one. Now, if I draw this one here, okay, now this one looks like they cross at the dotted line, so that could possibly be it. Look at this one here. This one has the dotted line, and that looks like it crosses on the y equals x line. So both of these look good as far as crossing on the y equals x line. Now, what I'm going to do is I'm going to find a point on the blue one and see if the inverse of it is on the red one. So what I'll do here is, okay, I'm just going to estimate this point right here. This looks like that's 10. This looks like it goes over 1, 2, looks like it goes over 3, 1, 2, 3, up 10. So 310, roughly, is on that line right there. So it means if I reverse those, 10, 3 should be on the red one. So 10, 3 looks like it's on that one. See here, 10, 3. It's not on that one. So this got to be C. That's an easy way of how you could determine if that's the graph or not. Okay. Now, part C here. Give the domain and the range of f and f inverse. All right, so the domain, well, on this blue line right here, the domain, it goes from -infinity to +infinity. And then the range, it goes down to -infinity, it goes up to +infinity. So the domain would be -infinity to +infinity, and the range would be -infinity to +infinity. Okay? Now, for the inverse, what's the domain of the inverse? Well, since this range is -infinity to +infinity, this would be -infinity to +infinity, and this would be the same as that. Okay? And there you go. Here's another one. All right, 16 here. The function is 1 to 1. Find the inverse. All right, so we're going to do the same thing we just did a minute ago. Let me get my piece of paper here. Okay. We've got f of x equals 9x plus 5. Okay. All right, we're going to do these 4 steps here. I change f of x to y, and then I swap x and y. So we'll go ahead and do those together. I'm changing this to y, and then I'm going to swap x and y. Okay, there we go. Now step 3, bring this back in here. Step 3, we got to solve for y now. So I already did step 1 and step 2. Step 3, I'm going to solve for y, which means I'm going to have to minus 5. That'll go away. X minus 5 equals 9y. And we'll divide by 9. And it looks like these cancel, so y equals x minus 5 divided by 9. There you go. I solved for y. And now step 4, I can change that to f inverse of x. So it means step 4 here, f inverse of x equals x minus 5 all divided by 9. And there you go. There's my inverse. X minus 5 divided by 9. Okay. All right, so x minus 5 all divided by 9. That's my inverse. Okay. Now state the domain and the range. All right, knowing my function here, this is linear. It's just a line. So this is going to have the same domain and range as the previous problem. So okay, see how this has braces right here? This means x is just certain values, so we would just put like certain values x can be. Well, this is not certain values. This is negative infinity to positive infinity, which I think is right here, D. The domain and range are all real numbers. Okay. So that means in the inverse, right there, same thing. Okay. Now, here's my graphs. Which one of these graphs is the correct one? So remember now, let me write it down here. Here's my original function. Okay. Which 9x plus 5, it crosses at 5, which would be right here. Okay. And then it goes up 9 over 1, which should be a line like this. This is wrong. It looks like this blue one right here. This one looks correct. And this one here. These two have the correct blue line for the function. See, this blue line's wrong and that blue line's wrong. Okay, now, the inverse of that. Okay, well, first of all, you see all these have the y equals x line. See here, y equals x, y equals x. And these two should cross on that, and that looks like they do there. And this looks like they do there. Okay, now which one is the correct one? So what we're going to do is we're going to check a point. See, so on this line here, now I'm looking at this one. This graph is not the same as this graph, so I don't know if this one's right or not. Let's see here. That's 5, and then it goes up 9 over 1. I think it's more this one. See, these are just a slight bit off. I think this is the graph of this line right here. So that tells me that would be the graph right there, A. You can try your point here though. This looks like 110 right there, 110, which means if I reverse those, 10, 1 would be right there, and I think that's my graph right there. Okay. This one looks like it would do the same thing. This looks like 210, which means 10, 2 would be on this one, which it is. But I don't think 210 works this. I think if I put 1 in for x, see if I do f of 1 right here, 9 times 1 is 9 plus 5 is 14. So 114 should be my point. And I think what this is right here. See, 114, this line is not going to hit it. So this got to be the right one. I don't know if I explained that well enough. You can see right here, we got the right one. It was A. Okay. Let's go to this one, number 17. Determine whether the function is 1 to 1. If so, oh, look here. It's x squared. It's quadratic. So see, it's going to do this, and it's not 1 to 1. It fails the horizontal line test. So it's not 1 to 1. So this is B. Okay. All right. Graph it. Okay. Well, right here, the function is not 1 to 1, so you can't do it. All right. Okay. This says give the domain and range of f. Select the correct choice below. Fill the answer boxes if necessary. All right. The domain. Okay, on this right here. I think this is what our graph would look like for that. Okay. Which means the domain is every time negative infinity to positive infinity. The range, it looks like it's 10 to infinity. Okay. So there's what the domain and range is of the function. All right, now give the domain range of the inverse. All right, well, normally the range here would be the domain and the domain would be the range. But it's not 1 to 1, so it's B. Okay, it's got to be 1 to 1 to have an inverse. All right, going to number 18 here. Determine whether the function is 1 to 1. If so, write an equation for the inverse function. Okay. All right, 7 over x. This is reciprocal function, which has a asymptote, but this is 1 to 1, so it should have an inverse. Okay, so we'll find that inverse here. Get a piece of paper here. We got f of x equals 7 divided by x. Okay. All right, so we're going to do our 4 steps for this. Okay, step 1, change that to y. Step 2, I'm going to swap them. And then step 3, I'm going to solve for y. All right, to solve for y, I'm going to multiply both sides by y to make this get out of the denominator here. So I have y times x equals 7. Okay, and then I'm going to divide both sides by x. So I have y equals 7 over x. And so I solve for y. And so now step 4, that means my inverse is going to be 7 over x. And there you go. So it's the exact same thing. All right, so the inverse is 7 over x. Okay, and I think you can see my answer right there. We're in good shape. All right, now choose the correct graph. All right, well, since these are the same, they're going to be the same graph, which looks to me like it's B here. B has the same graph on top of each other. See, it's not that one. These are 2 different graphs. And then we got this line here, which, that tells you it's wrong right off because it has no shape or form of the function. So the answer is going to be B. Okay, now give the domain and the range. All right, so in this function here, we have an asymptote right here, x equals 0. So that means my domain is going to be negative infinity to 0, and then 0 to infinity. Okay, now my range, it looks like we have a horizontal asymptote at 0, which means negative infinity to 0, and then 0 to infinity, which is the same thing. Okay, and now the domain of the inverse. All right, here's my range. That's going to be the domain there. Here's my domain. That's going to be the range over here. I'm not going to write them out. Okay, and you can see we got all that right here. Okay, number 19. Determine whether the function is 1 to 1. If so, write an equation for the inverse function. Okay. Get me a piece of paper here. All right, so this is another reciprocal function, rational big function, so it is 1 to 1. So let's write it down here. Okay. And x cannot be 7 because that's making us divide by 0, so that's an asymptote. So now step 1, I change this to y. Okay, step 2, I swap x and y. Okay, now step 3, got to solve for y. All right, well, like I did a while ago, I've got this denominator here. Y is in the denominator, so I'm going to have to multiply both sides by y minus 7. Okay, which makes this cancel, so I have y minus 7 times x equals 1 over here. Well, I'm going to have to distribute this, which means I have yx minus 7x equals 1. So I just distribute the x here in this. And then here's my y I'm solving for. So I'm going to have to add 7x to both sides, which means I have yx equals 1 plus 7x. And then now I can divide both sides by x, which makes this go away. And I have y equals 1 plus 7x over x. And there you go, I solved for y. Which means step 4 now, the inverse is going to be 1 plus 7x over x. There you go. All right, so 1 plus 7x all over x. That should be my inverse. Okay, just a quick check down here. Looks like we got it right. Okay, now let's go to B. If the function is 1 to 1, which it is, graph the function and the inverse on the same axes. Okay, so here we go. So we know it is 1 to 1, so that's not an option there. It's one of these three. Okay. Now, going to my function up here, x cannot be 7, which means on the function, 7, there's an asymptote. All right, so look here, 1, 2, 3, 4, 5, 6, 7. See, it looks like my asymptote right there or right here. So both of these look good, but this one here, see at 7, the asymptote's over here at -7. So this one's out. So just looking at the asymptote of the function here, that tells me it's one of these two. Okay. All right, now notice on the blue one, see how this one goes up? The left side, it goes up versus the left side going down here. Okay, so what I'm going to do is I'm going to pick something close to the asymptote like 6. I'm going to put 6 in. So up here on my function, I'm just going to do f of 6. I'm going to put 6 in this. So that means I have 1 over 6 minus 7. Which 6 minus 7 is -1. So f of 6 is going to be 1 over -1, which is -1. Alright, so that means 6, -1 is a point on the function. Oops, sorry. Alright, so 6, -1 should be on the function. So if I look at my two graphs here in between, 6 right here, this is it. 6, -1 is right there. See, this is 6, +1. That's not right. The answer is A. And we got the answer down here, A. Okay, now the domain and the range. Okay, so if you look at the function, we got an asymptote at 7. So that means the domain of the function is going to be -infinity to 7, and then 7 to infinity. There's my domain. Okay, now what's the range? Well, if you look at the range here, it looks like there's an asymptote at 0 on this. So it's going to be -infinity to 0, and then 0 to +infinity. So that would be my range. Okay. And now what's the domain of the inverse? Well, it's going to be this right here. -infinity to 0, 0 to infinity. And then what's the range of the inverse? It's going to be that. Okay. And then you see them down here. We're all looking good there. Okay. Number 20. Okay, here's a function here, and this is a reciprocal, so it is going to have an inverse. Okay. All right, let me show you how to find inverse of this one. So let me write it down here. F of x equals 4x plus 7 divided by x minus 2. All right. So step 1, I'm going to change this to y. Step 2, I'm going to swap x and y. Okay, and now I'm going to solve for y. So step 3, I'm going to solve for y here. Okay, now, follow me on this. This is going to take a few steps here, but I've got y in the denominator here, so I'm going to have to multiply both sides by y minus 2. Okay, which is going to make this cancel. And so now I have y minus 2 times x. I'm going to go ahead and distribute. That's going to be yx minus 2x. Yx minus 2x. I'm going to distribute those. That equals 4y plus 7. Okay, now I've got to get my y's on the same side together. See, I got a y over here and I got a y there. I need to get them together. So what I'm going to do is I'm going to minus 4y on both sides. So this will go away. And then this 2x, I'm going to have to add 2x to both sides. So that'll go away. And so here's what I have now. I've got yx minus 4y equals 7 plus 2x. Okay, and I've got my y's over here. Now here's the trick to doing this. I'm going to factor the y out of that expression. I'm going to take my y out of this, which means I'm going to have this x minus 4. Okay, and now I just divide both sides by x minus 4. This will cancel. And there you go. I solved for y. And now step 4, I change it to f inverse of x. And there you go. There's my inverse. So it's 7 plus 2x over x minus 4. Look here. Okay, same thing. All right. Oh, it says x cannot equal. See here, we didn't do that. But here, see, x minus 4, we can't have 4 because that makes us divide by 0, so x cannot equal 4. Okay, now, which one's the graph here? We know it exists because we just found the inverse, so it has to exist. So, all right, so all I'm going to do is I'm just going to check the blue function. This looks like a blue function and a red inverse. This looks like a blue function and a red inverse. But one of them has the correct blue function. So what I'm going to do is I'm just going to try a point on this. So I'm going to put 0 in. I'm going to do f of 0. That looks like it'd be easy to calculate. So if I put 0 in right here, 4 times 0 is 0, plus 7 would be 7. And then 0 minus 2 would be negative 2. This would be negative 7 over 2, which is negative 3.5. Okay, so at 0, my function should be at negative 3.5. All right, so at 0, negative 3.5 should be like right there, and I don't think this is right. Here it is right here. At 0, negative 3.5, right there. This is the correct one, B. And that's what this is down here, B. Okay, now the domain. All right, if you look at my function here, I've got an asymptote at 2. So that means I go from negative infinity to 2, from 2 to infinity. Okay, the range, let's look at my horizontal asymptote. Remember to look at the degree in the top, which is 1, the degree in the bottom, which is 1. They're the same, so I divide. 4 divided by 1 would be 4. Y equals 4 is my horizontal asymptote, which means this is going to be negative infinity to 4, and then from 4 to infinity. Okay, you can't really look at the graph until that because you don't know if it's 4 or 5, because see, it looks like it's kind of like, well, that is 4, I guess. But it's easier just to do the rules like we learned in the last chapter. And then, there you go. What's the domain range of the inverse? All right, there's my domain right there. There's my range right there. Okay, and that all looks good. Okay, now 21 here. Graph the inverse of the given one-to-one function. Okay. All right, so if you notice on here, the red one is the function, so you can see it on each one of these. Okay, now when you graph the inverse, it should intersect it on this line here, y equals x, which you can see on every one of these, it touches every one of them. Okay, this is not right because it's a straight line. It should have some shape of what the function is. So I know right off that one's wrong because it does not take the shape of the function. So every one of these other three, they do intersect on the line y equals x. Now all I'm going to do is I'm going to look at this function, and right here this looks like, what is that, 10, 2? This point right here is 10, 2, which means on the blue one I should have 2, 10. Okay, so 2, 10 looks like B. See here, 2, 10, 2, 10. It's got to be B. And that's what the answer was. Okay. All right, 22 here. Graph the inverse of this one-to-one function. Okay. So if you look at this now, the blue ones are my function here, okay? And when they intersect, looks like they intersect on the line there. Looks like they intersect. See if I draw this line here. Looks like they intersect on the line. This one, when I draw the line here, they intersect there, so I don't know if that's necessarily right or wrong. And these intersect on the line there, so now what I'm going to have to do is I'm going to have to find a point. So let's look at this. Let's see here. Let me get this one right here. This looks like 8, 10. Close to it. Oh, no, wait a minute. I got to do the blue one. That's the red one. Sorry about that. So let's look at this point right here. This is 10, 8. Okay, 10, 8. If I switch that, it would be 8, 10, which is what that is. Okay, see 10, 8 right there? I should have a point right there, 8, 10, which I don't here. I think A is my answer. Okay, you just check a point. And, yeah, the answer is A. Okay. Okay, on this one we just have 4 graphs here. The blue one is the function. Which red one is the correct inverse function? Okay, well if you draw the y equals x line, they should intersect on that line. They intersect here. This is wrong. This one looks like it could be right. This one looks like it could be right. These two don't intersect, which means that's wrong. Okay. All right, so those two are out. It's got to be one of these two. All right, so what I'm going to do is, here's this point right here. This looks like 10, 2. Okay. I'm sorry, the blue one's the function. 2, 10 right here. 2, 10 means 10, 2 should be on that one, which it is. And I think that's it right there. See here, 2, 10. You got to look at the function. You got to get a point on the function, and it matches up to the inverse. So 2, 10. 10, 2 is not on that one. So it's got to be D. And you can see right here, D is right. Okay, now. All right. The graph of the function is shown. Use the graph to find the f inverse of 5. All right, f inverse of 5. Okay, this is the x of the inverse, which means this is 5 and we don't know this value. All right, that means if I look at the graph, if I switch those, the function, see this is the inverse here. 5 is the x, and we don't know what the inverse is. All right, so if I switch this around and go to the f function, that means 5 would be the y on the inverse function. I hope this is making sense. So I just needed to go where 5 is my y and see what x value is associated with that. So if I go to 1, 2, 3, 4, 5 on the y, it looks right here, which is 8. This is 8. And you see the answer is 8. I'll do it all these here. Maybe that might make sense after I do all of them. So here's my inverse. See, this right here, this is the function of x right here. This graph is the function. But it tells me the inverse, find the inverse of -8. All right, -8 is my x on the inverse, which means it's going to be the y on the function. Okay, so I need to figure out what x has that y value. So I go down to -8, which is right here, and then right there, it looks like -8. What about 26 here? This is the function, but it tells me the inverse of 4. That's the x, which means that's going to be the y in the function. Okay, so I just go to the y is -4, which is right here, -4, and it looks like 0. 0. Okay, hopefully that makes sense. If you have questions about that, let me know. And the last problem here, number 27. An organization determines that the cost per person of chartering a bus is C of X, where X is the number of people in the group and C of X is in dollars. What does C inverse of 4 represent? Okay, all right, so C of X equals, let's just say $5 to ride this bus, 5X. Okay, let's just say that, where X is the number of people. Okay, so to charter this bus, it's going to be 5 times each person on there. That's what the cost of this charter is. Okay, so what's C inverse of 4? All right, so 4 is the X of the inverse, which means it's going to be the Y. It's going to be the y of the function, which means this will be 4 right here. All right, so I guess that's going to be B here. It's going to represent how many people can be taken for a cost of $4 per person. Okay, so X is how many people there are, and this is the cost. So 5. This function I made up, this doesn't really match with what we got going on here. But anyway, so this is how many, 4 is the y of this. So this right here is 4. So X would be how many people can go for $4. I don't know if that makes sense to you what I'm trying to explain or not. But anyway, that's it, man, with the inverses. Contact me if you need any help. I'm here for you. I'll help you all I can. Have a good day.